All right, welcome, hardcore students who stuck around for level 4. This is homework 21B, the level 4 section. This should be challenging for me as well as you, so follow along as best you can. Rewind when you need to. We're starting with this problem here, and what it's given is that x plus 1 squared plus y minus 1 squared equals 25. That tells us three things. It tells us that x will be negative 1 in the center, y will be positive 1 in the center, and the radius will be the square root of 25, which is 5. Therefore, we're going to go plot x at negative 1, y at positive 1. So here's the origin. So the center is going to be x negative 1, y positive 1. And the radius again is 25. So I'm going to take my compass, and what I'm going to do is I'm going to stretch it out 1, 2, 3, 4, 5. And remember, I believe in rotating the paper, not the compass. So I'm going to rotate the paper this way. Let's make sure that I don't lose my center. There we go. Rotate the paper. Okay. Now the next question is, what are the 4 points? And it gives us that A will be negative 1, 6. Well, negative 1, 6 is this point right here. So it's easy to tell that our 4 points are going to be these 4. Which makes sense because they are perfect intersections with the graph. So A is negative 1, 6. It doesn't tell us anything about B. It tells us that C will be negative 4 as its y value. So this is pretty easy to tell. The only one of the 4 points with negative 4 as a y value would be this one. So the coordinates there are negative 1, negative 4, which means I'm going to say that C is negative 1, negative 4. D is negative 6 as its x value, so that's got to be this one over here. And that would be negative 6, positive 1. So D is negative 6, positive 1. And therefore B has to be this one here. This is B. B is going to be 1, 2, 3, 4. 4 to the right and 1 up. So the coordinates are 4, comma 1. Next, it tells us that point E is to be at 5, comma 6. So we go back to the origin. 5 to the right is 1, 2, 3, 4, 5. 6 up is 1, 2, 3, 4, 5, 6. And what you may notice is that E is actually level with A. So that's very interesting. That's kind of a heads up. It says to construct line AE. So I'm going to do exactly that. Constructing line AE. What do you think line AE is? I'll give you a question. Is this a secant or is it a tangent? That's right, it's a tangent. It's perpendicular to the radius here. You see that? It only intersects the circle at point A, so it's a tangent. It's different from a secant because it only intersects in one place. Next, it's telling us construct line EC intersecting the circle at F. So what that means is we're going to construct a line from E through C. This is interesting. From E through C intersecting the circle at F. That means that this point here is F. Okay, now we've got this line, which is a tangent, this one here, which is a secant, intersecting it at C and F. Now we've got a series of questions. These are going to be some pretty challenging questions. First of all, measure of angle EAC equals. Well, this one probably isn't very hard. This is E, this is A, and if you look at AC, that's the diameter, right? So if that's EAC, then this is clearly a 90-degree angle because the diameter goes right through the center. Therefore, it's perpendicular to the diameter just as it's perpendicular to the radius. So that first one wasn't very hard. EAC is 90 degrees. Next, measure of angle ACE. Now that's going to be a little harder. Here's A, here's C, here's E. Fortunately, we're working on a graph, so this is really just a big Pythagorean theorem problem. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we're trying to figure out ACE, what we're going to do is a tangent problem. Our opposite is 6, our adjacent is 10. So in other words, the tangent is going to equal 6 over 10, which equals 3 over 5, which equals 0.6. So if 0.6 is the tangent, let's look over here on the tangent chart. And we're going to scroll down, scroll down, scroll down, scroll down, scroll down to right here, 0.6009. That looks pretty good. So I'm going to say that that's the angle. Therefore, we're looking at a 31-degree angle. So here we are. The measure of angle ACE is 31 degrees. Now, if we know that this one's 31, we can just do the triangle sum theorem to figure out that this one over here is 59 degrees. Okay, fair enough. Is it asking us that? Yeah, it is. AEC, cool. So that one was kind of cheap. That was easy. 51 degrees. Oh, sorry, 59 degrees. Okay, last one. Measure of arc AF. So here we are. Here's arc AF. And this is pretty tricky. I mean, this is quite tricky. But if you consider that this tangent functions just as a secant, then we know that this arc minus this arc divided by 2 equals 59. We know that because when you subtract the two arcs, the difference equals twice the measure of the intersecting angles. So this arc, clearly, arc AC is 180. So we know that 180 minus arc AF equals 59 times 2, or 118. Therefore, if we find AF alone, what we're going to find out is that arc AF has to equal 62 degrees. Now believe me, this is not an easy problem. I hope you understood it, but please rewind it if you need to see it again. This is about as high as geometry is going to get. This is actually pre-trigonometry, so if you've got this, you're doing really well. Take a breath. Okay, that was one problem. That was one hard problem. We're going to move on to another one that has to do with inscribed circles and squares. So get comfortable, and here we go.